Hello? Can anyone hear me? This is Rand here. Alright, great. I'm just going to give it a few more minutes, wait for some people to sign on, and then we can get started. Great. Okay, it's a few minutes past 1. I'm just going to go ahead and get started. Just by saying welcome, I'm Rand Shanak. This is a presentation on RN statistics. Jose Portilla is the facilitator. So I'm just going to spend a few minutes to introduce Starweaver and give some basic information so that you guys have some context as to the type of program that you're going through today, as well as some other programs that we offer. Okay. So Starweaver is an education and training company that's focused on the executive training businesses. We carry out business with several different organizations around the world, including technology companies, finance companies, manufacturers, and retailers, as well as many more for several years. So we do programs with pretty much any type of company on every continent. Essentially, executive education is either in-person or virtual. Sometimes they're relatively short, of about 30 minutes. Sometimes they're a little bit longer. They can sometimes be pretty broad and basic, and we refer to those basic programs as core programs. And sometimes they're a little more advanced and cover technologies, frameworks, and project management more in depth, as well as many other topics that you would expect a training and development company to focus on. Our programs are always hands-on and they're always interactive. They're taught by subject matter experts like Jose, who have many years of experience, and we ensure that these instructors always have two important criteria. The first one is that the instructor is an expert in the field, and the second is that they're exceptional presenters. This means that they know how to engage you, they're able to, and they're willing to take questions and customize programs in order to suit the audience's specific needs. So we have a number of programs coming up. RN Statistics is the one that you guys are going to do today. There are a few others that I encourage you to register for, which you can do by going on to starweaver.com/events in order to find them. You can see here that there's another program next week that we have going on Docker and Kubernetes, as well as a few coming up in December like IDLE, IoT, and best practices in IT. These are just a few. We're actually planning to add 1 or 2 more in December, and then we'll have a full schedule coming up in January as well. So again, our main goal here with these webinars is to give you guys a flavor as much as you can get about the topics that we're doing webinars on in about an hour's time. So as a bonus for participating today, you're going to get an access to one of these 17 video-based courses. They range from just a couple hours to up to 24 hours. You can see a lot of them are finance-orientated, and frankly, even if you're a technologist or a business analyst, we've done programs with many finance companies like Bank of America, Tata, Wells Fargo, and a lot of these organizations have tech people who need to understand the products and the services that the institution provides and is all about. So what we'd like you to do in order to have access to these courses is just to complete a survey at the end of the program. So you'll see the survey in the chat window. I'll send that out pretty soon. It's pretty simple. If you want to write it down, it's surveymonkey.com/r/HHCS85D. So just give a review. I hope it's going to be great. I'm pretty sure you guys are going to enjoy this. Once you finish the survey, you'll have access to any of these courses. So that's our brief introduction. I'm going to pass it off to Jose, and I'm sure you're going to have a great presentation.
Hey, can you hear me now?
Yep.
If someone could type into the chat. Yeah, you can hear me?
Yes.
Okay, awesome. Well, let me open up the presentation and get started. Let's actually show this site. All right. Hey, everyone. So, welcome to this presentation on R programming and statistics. My name is Jose Portilla. I'm the head of data science at Perry and Data Inc., and I'm an instructor and trainer for programming and data science, and I also teach on a website called udemy.com. I teach a lot of online courses there on various topics, but mostly data science, and R is a great language for that, so that's what we'll be talking about today. So let's start with a little bit of history background for R. So R is a programming language that evolved from something known as the S language, and it was first designed by Rossi Haka and Robert Gentleman at the University of Auckland in 1993, so over in New Zealand. And then later it was released as an open source language for free under the general public license. So just to show you how much R is suitable for statistics, the reason it evolved from a language called S, was called S because it wanted to be a statistical programming language. Basically, Ross and Robert were professors, and they were teaching statistics class, and they were kind of disappointed that there were no programming languages that were suitable for them to teach statistics, so they did the next best thing and invented one themselves. So what is R? Well, we just discussed that R is a programming language, but it's also more than that. It's a software environment for statistical computing and graphics. The R language is widely used among statisticians and data miners for developing statistical software and data analysis. And what's nice about it is it compiles and runs on a wide variety of Unix platforms. So if you're using Ubuntu or Linux, it works there. It also runs on Windows and Mac OS. And R can be downloaded and installed from a CRAN website. And CRAN stands for Comprehensive R Archive Network. And it's basically this entire network of other packages. So why choose R? Well, R allows you to have the most extensive modeling resources in scientific research. And it makes it really easy to publish quality graphs or quality images, including interactive plots, which I'll show you examples of later. It allows you to easily develop your own statistical models, so you can share them either with your coworkers or for some sort of publication. And best of all, it's freely available under the general public license, so you don't have to pay some sort of license fee to SAS or SAP or that kind of thing. This is totally free. It's open source. Now you can contribute to it if you develop a great package that you want to share with the world. It's a great community. So packages for R, it's a big part of R. So let's go ahead and just briefly discuss it. So package is basically a collection of R functions with comprehensive documentation. And a package includes things such as R functions, data examples, help files, namespaces, and descriptions. And the default installation is kept as a minimum. So if you find a package online for something like reading an Excel file that you want to use, it's basically a one-line at your command line to install that package. And that package, in order to be part of the archive network, needs to have examples, help files, namespaces, descriptions, etc. That way, it's very easy to learn how to use a package you're completely new to, because in order to be a package, it needs to have all this stuff with comprehensive documentation with it, which is great. And the function of R could be extended by loading local R packages. Now let's go ahead and discuss R GUI, or graphical user interfaces, and interactive development environments. So the graphical user interface for R, a lot of other languages tend to have lots of heated debates as far as what is the best interactive development environment or graphical user interface for a programming language. Luckily for R, it's basically just RStudio has come out on top. There's a few other options, such as things like Jupyter Notebooks or just using a text editor, but really almost everyone who professionally uses R is usually using RStudio, which is great because that means you don't have to deal with a bunch of competing IDEs. RStudio kind of has one. And this is what it looks like. So you can see there's essentially 4 panels there. And we'll explore this later on after the presentation. I'll open up RStudio and kind of show you what's possible here. But there's usually 4 panels. You have a console panel on the left, the lower left-hand side, a script panel on the upper left-hand side, and then your workspace and history are on the upper right-hand side, and then your files, plots, packages, and help are just in different tabs on the lower right-hand side. So you can see here you have a really nice working environment where you can easily write a script, run stuff on the console, check out your workspace, check out the history of all your commands, and then check out the plots. And then after you've done something like this, where you wrote a script, set up the plots, have your console ready to go, you can easily just export your plot to some other file format where you want to paste it into a PowerPoint presentation or something like that. So let's talk about just various R features in order to convince you that R is a great programming language choice for statistics and analysis. So as I mentioned, R is open source. So the source code of R programming and the extensions could be examined line by line. So if you ever have a doubt if something's not working the way you want it to work, you can open up the source code and check it out line by line. Definitely can't do that for other paid packages. And then integrating with other programming languages is actually pretty good. R is an interpreted language, so it can be rather slow, but you can integrate it with high-efficiency languages such as C, C++, or Fortran. So because R is interpreted, it means it's usually easier to write, so you don't spend so much time developing code. It can be a little slower, not a whole lot slower, but a little slower than some of these other extremely fast languages, such as C, C++, or Fortran, but you can integrate it with these high-efficient languages, so you can write an R, integrate it with something like Fortran, and gain all that speed and save the development time, which is nice. It also has operating system independence, so it doesn't matter if you're on Unix, Linux, Windows, Mac OS, etc. It'll all work. R works on all of those, and it's command line driven, so you have to write the commands. But that's actually a good thing because you can see it's really easy to set stuff up for automation in that case. All right, let's talk about R features for statistics and also just some general R features. So R is really the most comprehensive statistical analysis package available. R by itself comes with batteries included. It incorporates all of the standard statistical tests, models, analyses, as well as providing a comprehensive language for managing and manipulating data. So R already, just without downloading any packages, basically includes any sort of statistical test you would want right out of the box. Things like t-tests, chi-square tests, normal distributions, QQ plots, those kind of things that are considered standard statistical analysis packages. Those already all come with R. So it's extremely comprehensive in that format because that's basically what it was created to do. So it's a programming language environment developed for statistical analysis by practicing statisticians and researchers. So as I mentioned, this is basically what it was created to do, is statistics itself. And what's also really nice is the graphic capabilities of R are really outstanding, and we're going to show you some examples after this presentation. It provides a full programmable graphics language that surpasses most other statistical and graphical packages. The graphic capabilities of R, I think, cannot be understated. When you start plotting with R, even if you dislike R as a programming language, you quickly fall in love with ggplot2, which is the plotting package for R. We'll show you some examples, but you can manipulate every little detail of a plot, and you can do it in a way that makes sense and is organized. Unlike some other languages where it's really difficult to get into the nitty-gritty of a plot, R has some really great capabilities and a really nice organizational structure when it comes to plotting graphs. As I mentioned, R is free, it's open source, and anyone can modify it. So as far as R packaging, R has over 4,800 packages, and I think this number is actually outdated now. It must be over 5,000 or 6,000. But it has over thousands of packages available for multiple repositories specializing in topics like econometrics, data mining, spatial analysis, and bioinformatics, etc. So if you find yourself in a particular field of study, for instance, maybe you are trying to study financial movements for stocks, things like that, there's definitely already R packages for that. So if it's even mildly related to statistics in some way, there's tons of R packages for it. So if you want to do something like back testing some trading algorithm, not that I'm suggesting to do algorithmic trading with R, don't take this as financial advice, but there's definitely packages to do that and test stuff out. So if you can think about it, it's probably already been done for you in R, so you can download that package, and like I mentioned, it's all open source. So if you want to edit these packages in any way, you can see line by line what you can do with it. So that's really one of the main features of R, this extremely wonderful package community with great documentation of these packages. And as I mentioned, R is cross-platform, can run on many operating systems and different hardware. That way you don't have to worry about your coworkers not being able to run R on their computer. So I'm going to explore RStudio and some real code just to show you an example of what you would kind of do in a training session. Let me escape out of this. Okay, so I'm going to walk through some notebooks just to show you examples of what's capable of R, and then I'll also show you here on my bottom I have RStudio open to show you what that looks like, give you more of a tour of what's possible with RStudio. But here are just some example notebooks of what I use when training. So whenever you're doing a training, you have full notebooks with written out details here and the code in these cells, so you can just copy and paste this stuff into RStudio and see the expected output. So this is just an example of what it would look like to solve a logistic regression, which is just a classification statistical model. And here we're working with the Titanic data set from a website called Kaggle.com, where we try to predict whether someone survived or died on the Titanic. So you can see here, R is very capable of reading in almost any file format that's in a tabular format, whether it's SQL, CSV, or Excel. It can read it with no problems, and it makes it very easy to read. You can see here it just says read dot, and then you choose the file format you want, and in this case I'm just a CSV file, and R works in what's known as data frames. So data frames you can think of almost like an Excel spreadsheet, but with R you can manipulate them and explore them with ease in just a few lines of code. So you can do something like an exploratory data analysis. So in this case we wanted to explore how much missing data there was. So we imported this library called Amelia, and it's called Amelia after Amelia Earhart because she disappeared. So you can see there's a little bit of humor to these package names. But in this package, it allows you to graphically map what data is missing. You can see here we're missing some age data off of this Titanic analysis, but it makes it really easy to just visualize this stuff. So here I'm calling ggplot2, which is the main library for data visualization. And what's really cool about ggplot2 is you essentially just add layers to the plot. So here I say ggplot, get that training data or that Titanic data, whatever feature or column I want to plot, and then add plot types to it. So here I'm kind of zoomed in so you can see this, but I have a bar plot here. Then you can color your bar plot by a certain factor. You can continue this. You can do a histogram here with or without bars in between them. There's a lot of customization. You can basically do whatever you want. Here's a count plot. Here's what they paid for their fare with a little bit of alpha so you can see through. R also makes it very easy to clean your data. You can do box plots very easily with R and check those out. And then this is what normal R code looks like. So you can also do complicated logic with R, and it's organized by bracket notation. And then we rewrite the missing map again. And then you can build, what's really cool is statistical models, such as a logistic regression model, which is a common model used for classification. So here I'm trying to predict whether someone survived the Titanic, but you can apply this sort of thinking to something like predicting whether a part will be effective or not based off its features, or predicting whether someone will purchase a ticket to a flight, or predict whether someone will respond to an email. Logistic regression is used for all kinds of analysis like that. So it's very easy to train these statistical models. You just select the data you want, and then you come down here, if you'll notice, train the model. And this is a one-line logistic regression. If you've ever dealt with other languages, building your own model is usually very difficult, but R, this is all built into R, so it makes it very easy. It's just a general logistic regression, and what's really nice is this summary call you can do on a model, where it basically does all the work for you and writes out a whole report. So you can see what features were important based off their coefficients. You can see the z-values, the residuals. Residuals are just your prediction versus how off you were from the actual result. You can see the probability of that being an important feature, significance code, degrees of freedom, Fisher scoring iteration. So all the statistical information you want can be gotten just with this summary call. And that's basically for logistic regression. You just call one line once you have your data in the right format, and you've explored a little bit, and then you just call summary off your model, and you get this really nice looking report. And you can save this, organize it, share it with your colleagues, etc. So it basically makes you look like a statistical genius, but you just had to call 2 lines of code, which is nice. And then you can create predictions off of unseen values. So you train off maybe some customers, see whether or not they'll purchase something, and then when you have new customer information, your model can predict whether or not they will make the purchase. So that's just a simple example of what a machine learning library would look like. And I want to show you just a couple more capabilities before we jump to RStudio. R also has great capabilities to deal with timestamp information. So if you ever are working with other languages, sometimes it's really difficult to deal with dates. Maybe you're working with an Excel file. So R can read in that Excel file. And a lot of times you have dates in all kinds of formats in an Excel file. Maybe you have it in this more standardized format, but sometimes you even have words like November or NOV. R comes with the capabilities to just parse through any of that and make sure that you can choose whatever format you want for your dates and times. And here's just an example notebook showing that. So you can see whether we have it in this sort of notation or this notation or full November, we can clarify whatever format we expect it to and easily parse through our data. So a lot of R is built for cleaning and parsing your data, and you can put it into whatever models or visualizations you want to do for it. And this is just an example notebook with lots of description on how to actually do all this. So during a training, we give you this notebook. I walk you through it, how it all works, and then I give you some exercises for it. Okay, and then also regular expressions. That's another capability of R. You can easily just grab all string data and do any sort of analysis on it, counting how many words show up or counting patterns, etc., looking for stuff. It's all there, just any regular expressions that you're familiar with. It's just pattern searching, typically in a string, is very easy to do in R. Web scraping of R, it's not the most popular thing to do with R, but it's definitely very capable of doing it. So if you understand like things such as HTML and CSS, you can use the RVest library of R to actually grab data straight off the internet. And you can see it's actually very easy. So here I'm just essentially passing in some IMDb URL. This one's for the Lego movie, and just with a few lines of code, I can read out who the authors are, any HTML properties, CSS, etc. So if you ever want to automate reading a website, maybe you want to automate reading some sort of a customer URL, you can do that easily with R as well and put that into your script, which is nice. SQL with R. R is very capable of SQL. Depending on what SQL database, it's going to be a little different for you. But things such as MySQL, Oracle, Microsoft SQL Server, Microsoft has put a ton of effort into supporting R in its Azure environments. So it's all capable. If you have a SQL database, it's a tabular format, you can easily use R to grab information out of it. And here you can see it's very simple. You just install a package, load the package, use the connection, and then you can use your SQL knowledge as well. Here I'm saying select asterisk from table. So if you're familiar with SQL, you can even just type straight SQL, and R will then read it for you. And here's just an example of a linear regression that you can do. Here we're trying to predict student performance data, very similar to logistic regression, except we're just doing a basic linear fit. So again, we can read in data, and just with, you can even get a summary of your data itself. And R is smart enough to read in your data from a CSV file, show you your data, and then give you a summary of your data, which is a statistical summary showing you medians, means, quartiles, etc. So really great stuff. And then you can eventually check it out. So it'll give you even more summarizations. And this is just what R is really good at. Even with just like a one-line code, you can find out so much about your data. Then you can do correlation plots, which is really cool. Again, I keep repeating myself here, but that R makes me say this. It's really easy to do all of this. This is just one line of code. You type in core plot, and it gives you this really nice looking correlation plot. So you can see the correlation between all your features and your data set. And you can do a core gram, which is a little more advanced, but basically this entire visualization here, there's a lot of statistical information here if you know how to read it, but this was all done with just one line of code essentially, or 2 lines, I guess. And then again, you can always just visualize your data and build a model. It's very easy. You can see here that training a linear regression model is just the same as building any other model in R. You type in the formula you want to pass in your training data and see the summary, and here is the total summary. So again, making you look like you spent hours working on this when really it was just a one-line call, which is really cool. All right, and then here's some more statistical information that we explore. And you can get things such as residuals versus fitted, normal QQ plots, scale location, etc. Residuals versus leverage, lots of statistical information available at your fingertips, which is really nice. And then something else you can do, if you really wanted to, was things like natural language processing and getting information straight from Twitter. So something that's really popular to do in R, I'm not sure actually why, but the Twitter packages for R are very robust, and you can easily read information off of Twitter. Maybe you want to do some sort of a sentiment analysis on Twitter. R is capable of doing that, so you can use your regular expression stuff, text manipulation, grab stuff from Twitter, and in this exercise we actually end up creating a word cloud from Twitter. And then lastly, what I wanted to discuss was RStudio and something called Plotly. So I wanted to show you briefly some examples of how this actually all looks, and then I'll open it up to questions anyone has. But I'm going to open up my RStudio right here. So this is typically what RStudio looks like in a little bigger picture, and this is what you work with when you're doing a training session or just working with R in general. But you can see here you can write in a script, you can run the source of the script here, and you'll get the console. So if you want to do things line by line or debug, you can use the console. RStudio has really nice debugging capabilities, so in case you ever get stuck in your code, you can do that. And you can see here I've opened up, I basically created, this is creating some data, this is creating a plot, and here we have an interactive plot that we can export to HTML or any website, and I can zoom in on this plot, highlight over points I'm interested in, and get information from them, continue to zoom in, etc. This is all done in just a few lines of code with R. And there's not really many languages that can do something this interactive with R in just a few lines of code, because this is just 12 lines of code to both create the data and plot the data. And what we're using here is something called ggplot and ggplotly. So to show you some more examples, I will go to their official website, which actually had open. Let's go back here. So this is an example of what ggplot can do, but basically it allows you to take your ggplot code and put a plotly wrapper around it, this is just an open source library for R, and you can zoom in, check out specific data points, automate the coloring for it. Really cool stuff here, and all plotly graphs are interactive, and then you can do multiple graphs here. So here you're just checking the quality of some diamonds, and you can zoom in and check them out because you're looking at a particular point, etc. So there's all kinds of basic charts, statistical charts. Here's an example of some ribbon charts you can do. So if you're trying to do some time series analysis, R is also especially built for that. ARIMA models, all of that stuff. R is really easy to use. So here you can see some more statistical information plots. And I keep using that word statistical information, but really, I mean, that was the whole purpose of R when it was built by these professors. It's definitely expanded from them, but you can see here that even in the plotting capabilities, R is still very much statistically oriented. So you can see here, like, you can make these really impressive looking plots with not that much code, considering the data is also being created in this. And then you can do even more complicated plots, such as a dendrogram, to see the correlations or group fittings between two groups of variables here. All right. So let me open it up to questions. I know I just kind of blasted a lot of information at you. Let me open up GoToMeeting. Does anyone have any questions for me so far? Can you guys still hear me, hopefully? Oh, what? Is it connecting to audio? Hello, can you hear me? Okay. Do you want me to answer any other questions or anything? Because I'm getting a message that says I can... Sure, that's fine. Yeah, you can just send me an email if you have any questions. Yeah, no problem. Thank you. Anything else you need from me? I can't really tell if you're still able to hear me or not.
Unmuted.
I think we're all set, Jose. If there are any questions, I'll just send them out in an email. And I have it recorded for those who missed it, so if they have any questions after they see the recording, I'll also email those to you.
All right, sounds good.
Great. Thank you very much.
Bye.
Bye. Have a good one.